Hello, everyone. My name is Adedoyin Aromolaran,
I'm All-Tai.
I'm Tobi, Elutilo.
and this is our CS470 data mining project. So our project is just about finding useful prediction patterns in the usage data of credit card holders using data clustering. And basically, we just want to find out what other features we can predict about any given user's credit card account using clustering methods and techniques. Our data set is a Kaggle data set that was updated by Arjun Basin in 2018. It has 18 attributes and 8,950 rows.
So for our data set, we have about 18 attributes, and most of them range from either categorical or numerical, given the specification. Now that we're dealing with credit cards, I feel like we can say most of our data is numerical. And then these are the two methods that we've decided to use. Dorian will further explain them, both k-means and optics/dbscan.
Yes, k-means is just a clustering method where you randomly assign centroids and find the best positioning for those centroids based on the closest data points to them. And optics clustering is a method where you define a general density threshold and assign points to meet that threshold. Using the k-means clustering here, we graphed our results. Note that for any k number of centroids, they always tended towards 0 because the purchases data was always very low in contrast to the balances data. And that's why it has a bar-like structure. But this visualization will help us understand more things about the data in the future. Ty?
So for optics, here we have the unclustered and the clustered graph for the credit limit versus the balance. When I ran optics, it gave a lot of points that had noisy data, about 6,000 or so had noisy data. So I'm going to show graphs of them with and without them if you go to the next slide. So basically you can see that the ones without the noisy data are kind of just zoomed in on a smaller region. And so here we see that one of our big findings is that in terms of the balance and the credit limit, the only ones that have a balance that are even like remotely close to their credit limit are the ones at about like the 3,000 plus range. And if you go to the next slide, when we compare these to other attributes, they really don't show much of a difference. They're by themselves in terms of the balance, but like among the purchases and even over the next few slides, they still occupy the same range of like, here's purchases, and the next slide is cash advance, still the same range. The next one is payments, and it's still the same range. So even though the balance is a little bit higher and higher in comparison, it still occupy the same range of other features.
So the differences that we found in results for the k-means and optics clustering was that k-means clustered all the points, while optics left out around 6,400 to filter out the noise. And as you can see, just the difference in visualization of our clusters that I mentioned earlier is that how the optics clustering took out all the noise, so it looked wildly different to the k-means, while k-means was very sensitive to the data, and which resulted in the bar-like structure. There's also a different number of clusters. K-means the optimal amount of clusters was 12, while optics it was different based on what data you were clustering on.
Optics was about 10.
Okay, so yeah, we just wanted to predict other features, and this was how we predicted. And our summary is that high balance group was not always dissimilar for optics, and k-means was much more sensitive to noise. Thank you. All right, stop the recording. Hello?